All right. Good morning, ladies and gentlemen. Sorry, I just double record. I use a screen recorder and I use Teams to record because if the internet disappears, then I can still continue recording by the screen recorder. I always double record. My presentation I've already presented on Tuesday, but like all presenters, when you present something a second time, I'll not present it exactly the same. It will be slightly different, and I made a few little changes to my notes. So I know that a majority of you are qual, but you never know when you may need quantitative data collection. But we will do a comparison between the two nevertheless. So this first section is applicable to both disciplines, or however, when we get to the second half, or actually second 2/3, because the third only deals with data collection, will be SPSS and data analysis, which really has little to do with qual, although it is possible to do a bit of qual in SPSS as well. So there's all my details, and this is the first section, which is quantitative data collection. It's more theoretical, the presentation, but then afterwards I will show you the practical application of what I'm talking about through some of my students' examples. I'm sorry, I like to walk around, but I can't because I'm recording, so I'll have to stay here. So what is data collection? Well, it's a systematic gathering of information on a specific subject. Primary data collection, you collect from the original source. So you will go to respondents. Generally, you're collecting from people from companies, universities, wherever you go, you collect information from them. Secondary information, which all of you need to do in any event in terms of your literature review, is extracting and taking information, organizing, analyzing it from other researchers. Examples, typical examples of data collection is organizational records, surveys, results, journal articles, books, case studies, theses, government statistics. So yeah, by the way, all of these notes are on Blackboard already. If you don't have access to Blackboard, for those of you specifically that are doing quant, I will get your email addresses afterwards, and I will send you the video and the notes, which I'll send via WeTransfer, because CPUT's Mimcast is suspicious links for everything, and then no one gets it. So data basically empowers researchers with essential information that they need to validate their research questions, and if you have hypotheses or propositions, it allows you to prove that. Now, what are the differences between quant and qual? So firstly, qualitative gives you an in-depth understanding, whereas, and it could be an intangible problem, whereas quantitative is precise and gives you numerical results, so yeah. And this is the trend that will follow. Qual is informal, unstructured, semi-structured. Quant is very structured. There's no flexibility, okay? Qualitative is how and why, whereas quantitative is how much, how many, and how often. A small group is suitable for qualitative, so you're not looking at hundreds of respondents. Generally, if you have around about, until you reach saturation, but 20 to 30 respondents would be more than enough. And even at master's level, the average number my students do is usually 12 to 15. And that's enough for master's. Doctorate's a bit different though. Although I've had a doctorate student who had 12 respondents and did a whole thesis on that. Whereas quant involves a large number of respondents or sample population. It's much. The more you have, the better, in my opinion. Open-ended questions is generally for qualitative, closed-ended for quantitative. Qualitative provides rich, valuable insight, whereas quantitative is precise numbers. qualitative description, conceptual, quantitative is counted, measured, and aggregated. Qualitative is, they say questionnaires and tools are easier to develop. It's usually an interview guide, semi-structured or unstructured interview guide is what you use, whereas questionnaires and tools are difficult to develop. So generally, you take the constructs from other existing research. You cannot just make up what you're asking, you adapt it from other research, and that is essential for a number of reasons. If you just make, I've had students do this, and now you do the stats, the validity and reliability doesn't work, you throw away the data. I've had students throw away 3,000 questionnaires already. No reliability and validity, they start again. So that is, it is essential that you get it right, but we'll talk about that later. Qualitative, subjective, interpretive, exploratory, whereas quantitative, numerical, objective, inclusive. You can manipulate the qualitative data any direction you want. Okay, you can find what you want to find. You just need one person saying this, and you can use it. Whereas the other 11 people could say something else. But because one person said it, it doesn't matter if one person says it or 10 people say it, it is valid in qualitative research. So you can find what you want. Quantitative, you cannot do it. It's black or white. You found what you found. There's nothing you can do to manipulate the data, unfortunately. So, yeah. And then the last section, analysis rules are not well defined. So you can, as I say, get away if you want to, whereas quantitative analysis, they're established. Okay, so those are the differences. Yeah. Also, just to say that qualitative, we had this discussion yesterday, qualitative data, it's easy to collect your data. You can go to 10, 20 different people in 2 days and have interviews with them half an hour each and you're done. Your problem comes when you have to analyze the data afterwards. Now you're in Atlas TI, you're developing themes and this, and you've got 50 to 100 pages of transcripts, and now you've got to extract your information. Quantitative data, it's a pain in the butt trying to get 400 or 500 respondents, and it's going to take you a long time to do it. But once you've got it, the analysis and what you find, there is no, it is what it is. It gives you the results, clear cut. So that's the difference. Most doctoral students have a mixed approach. Some quant, some qual is what I usually advise. It depends where you're collecting the data from. Like if your research population is just CPUT, then I do both, quant and qual. Maybe do quant amongst the students and qual amongst the staff, depending on what your topic is. But if it's across South Africa, then you could just do qual, across. So it depends who the respondents are. Right, data collection factors. So let's just catch up to myself. So factors you need to consider is obviously what is your hypothesis or research question. If you have a research question, does it lend itself to qual or quant? The type of data, you have quant or qual. The data respondents you collect from, how many. The key is, and this we had this discussion as well, is do you have access to the people you need to collect the data from? And so just from a student's title, I say, if I see your title, I can see your study from start to finish. I should be able to, if your title's constructed correctly. So that will, often your title just says, okay, that's quant and that's qual. I'll be able to tell you just from your title. And so do you have access to the respondents? That is key, because people come up with these brilliant titles and say, are you going to be able to get permission from this organization to collect the data? That is key to your whole research, is having access to who you want to conduct the research among. The time frame, how long do you have? Qual is very quick to collect the data. Quant could take you a long time. So you've got to take that into consideration. The data collection methods, that we will talk about that later. And then obviously your resources cost. It costs money to collect research, but since COVID, everyone switched to digital collection. So now no longer for qual do you need to travel around South Africa interviewing people. You can just hop onto Teams or Google Meet or Zoom, and you can interview anyone in the whole world. You're not limited. Likewise, with quantitative data collection, you can just create a Google form and you can send that, put it on social media or send it to people via email around the world. So data collection doesn't need to cost you anything anymore. Okay, it's since COVID, it's kind of opened the world to that. Quantitative data is specifically the measurement of behavior and attitudes and opinions, usually to reject the premise or accept the premise or hypothesis. It's numerical, we've covered this. It's quantifiable. We're looking at statistical significance. In other words, p-values. Are they significant or not? We'll get to that later. The data consists of mean, standard deviations, frequencies, and a host of other weird and wonderful terms, which we'll get to later. Generally, the software that I use is SPSS and ANOS for structural equation modeling. But with SPSS, you can do everything you actually need. It's just if you want to get very fancy, then you go to structural equation modeling. Obviously, an app sample size is important that can be extrapolated to a bigger population. So it's no use me just doing a survey of you, 30 people. Is 30 people going to represent 1 million people's thoughts? No, there are specific parameters that you need to, but if you took a sample size of 500, 500 would pretty much cover the whole world. If you're in a global survey and you did 500 respondents, that should be enough. Right. Quantitative data important, so it is objective and can communicate precise information. We've covered this. It quantifies a particular problem. We've covered this. It needs extensive sample sizes. It's better to collect data from a large cohort. So if you're doing, there's a small number of people, it's better to speak to them and do qual. But if there's a large number of people you want to interview, quant is fairly good. That's more feasible, and it allows you to segment in smaller groups. So you collect data from 500 people, and you've looked at the attitudes of, let's just say, intention to purchase of something. Now you want to see, is there a difference between male and female? Is there a difference between age, different age groups in terms of the purchase intention? So you can break it down, and that's where you find the really exciting results. So that's a big advantage. So the major collection techniques of surveys has absolutely nothing to do with qual. It's I'm actually wrong. You can have qual in a survey because you can have open-ended questions. But for my master's students, I do not recommend open-ended questions because we can't analyze it. And I'm using a mixed method. The moment you've got a whole lot of open-ended questions where they give different answers. If the open-ended question they're giving similar answers, then you can still categorize it later, and you can run those stats through SPSS. So it's commonly used by postgraduate students. So that's what they use. It measures attitudes, beliefs, and opinions. Administered face-to-face, telephone, computer, online, WhatsApp, Google Forms. How you collect your data is opened up now. Previously, it used to be mostly face-to-face, telephone, and you used to even mail, post. Also, if you're going to post something in South Africa using the post office, they're going to get there quickly anymore. So now, these days, the most common way to collect data is digital. And my students, even now, they create a Google form, they create a QR code, and then they go to participants and they just scan it off their device. And then they can just fill it in. Or on their device, they open the Google form, they say, here's my tablet, cell phone, please complete. They complete, enter, next person. So that's how people, you're not walking around with a piece of paper anymore, you're walking around with your phone. And that's how people collect data these days. Likewise, you can do your qualitative data collection the exact same way. If you've got Teams on your phone, you can interview someone on the phone face to face, you can see their face, so digital has sort of transformed data collection. Right. Questionnaire tips. So the objectives of the survey, what are they? Are they strategic? Is it for a company or is it academic? That is actually going to have a role. Indicate the information required. So make sure, obviously, that these are all referenced from literature. So when you're doing quantitative data collection, you need to have done the background research, all the different constructs you're developing, and they all need to be referenced. Consider interviewing techniques. So is it what I covered? Online, face-to-face, self-completion. Do you need to interview people? Questionnaire think tank. So when developing your questionnaire or your interview guide for PAL, don't just do it yourself. Go to your supervisor, go to other people, get them to, once you've created it, give it to other people to give their input. You know, that's very important, not just yourself. Determine the questionnaires content. So the key is questionnaires can become very long. And the longer it becomes, the less chance of people fully completing it. So you need to ask yourself, is this questionnaire needed? Okay, or is it a nice to have? So to try and keep it, will they be able to answer the question as well? You may answer questions and no one can answer, then that's also a problem. The approach, is it direct or indirect? Are you collecting the data, or are you going to source it out for someone else to collect the data? That's going to play a role as well. Decide on the response formats as well, open-ended versus closed-ended. Create the related questionnaire sections. So I will show you examples of questionnaires, what they look like. I generally start with filter questions, usage characteristics, demographics, and then the scales. I'll show you an example. Determine the order. So I've just mentioned that. Consider the layouts. Also just mentioned it. Analyze each question individually. So the wording, it needs to be simple, clear wording. Be careful of double-barred questions. You can ask a question, 2 questions in one. And then they say, well, if I think of it this way, that would be answered. If I answer this question that way. So your questions need to be unambiguous and not biased. You can steer people to answer in a certain way. If you construct the questionnaire, you can get the answers that you want them to give if you write your questions in a certain way. And you can do the exact same in qualitative research as well. You can push people in certain directions. So you have to be careful that your research is objective and you don't phrase your questions in a subjective way. Translation of the questionnaires. So, you know, we live in South Africa with, I don't know, 11, 12 official languages now, it keeps increasing. You know, depending on who you interview, if it's just in English, certain people may not understand the questions. So you may need to consider translating your questionnaires. Most important in quant and qual is pre-test your research instruments. Go and do a dry run with your semi-structured interview guide, with your questionnaires. Go and interview 30 or 20 people. Run the stats, see what the problems are. Because now you may just take time to do 20, 30 people for quants, and then later on you do 1,000 people, and then you find this problem. So pre-test is vitally important. Reproduction. So if you're doing print, make sure it's a good quality. The print is not too small, that people are able to read it. And if you're doing electronic collection, you need to make sure you have the correct email addresses, and you know your Google Forms is efficient. And then run the questionnaire in the field. So if you're using field workers, you obviously need to fully brief them. So those are just some tips. Survey development questionnaire. So first you need to ask, who is the target audience? Do we have access to them? I've already covered that. Which questions will we ask? We've already mentioned. You can't just have nice to know questions. You really just need to put the essential in a questionnaire and your interview guide. You don't just want to ask, you don't want to extend and make the research too long. How will you reduce bias? In qualitative research, there's always going to be bias, I'm afraid. You're never going to eliminate it. It will be subjective. But in quantitative research, you can, through validity and reliability and carefully constructing your questionnaire. So what is a questionnaires length? Ideally, for masters, my students' questionnaires length is 2 pages, and it takes less than 10 minutes to complete. But I've got some doctoral students with 6 or 7 pages, which is going to take a good 20 minutes to complete. But you've made everything closed-ended so that it's quick through. The moment there's open-ended, it just increases the length of the questionnaire. What is the best way to disseminate? We've already discussed this. And do you require incentives? So some people, you know, you need to actually incentivize to complete. If you've got funding, if you incentivize people, you're going to get a much faster and higher response rate. I remember at some of you were in my class at BTech level, they had to do research for me. And so one girl early in the year, she printed out questionnaires. And while they were waiting in queue to register, she went, here's a suite, and you've got nothing to do, please fill in the questionnaire. She did 800 questionnaires in one day. One day. You know, she was finished, you know, and so she got a 10% for a course just like that. So incentive and also the right times. If you're doing students during registration, you know, people waiting for their student cards. I looked at that row and thought, oh, there's 500 people there. You could just survey them one time, you know, get all your data in one go. So we need to look for opportunities. Right, survey questions, so closed-ended is preferable because that allows you to create graphs, tables, numbers, and charts. Open-ended you can have, but it just they're now using a mixed method. Initial filter questions screen out questions, but we'll discuss this later because often you'll say, do you use Instagram? And they say no. But then they complete the whole questionnaire and they say, how often do you use Instagram? Daily. And now they say no, but they're saying they use it daily. Can I use the questionnaire results? Of course, because they're saying we use it daily. You know, so, but if you collect via electronic means, you can filter that out. You can have your filter questions and only give them the option yes. And if they don't click yes, they can't submit. So there are ways to do that. So often people say no, 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 and then they fill the questionnaire in saying the complete opposite. I tell my students you can use it because they obviously don't understand what filter questions are. Multiple choice questions and Likert scales are commonly used. Multiple choice Likert scales and dictonymous, yes, no. Although yes, no really does not give you much information. You can't use those stats for very much. And refer to question examples I'm going to show you. Then interviews. So like you get a qualitative interview, you can do a quantitative interview. And in these quantitative interviews, it's structured, whereas qual is unstructured or semi-structured. It should be written, closed-ended, so you ask them the questions and you just fill in their answer. Okay, must use the same questionnaire and the same sequence, whereas qualitative, you can mix it up. They jump to this question, you steer them there, you know, they can be all over the show. Observation can be quant and qual as well. If you use observation for qualitative, then you're generally just taking down structured observations, the numbers, how many times people do things. The observation can be watching someone maybe purchase a product or what they do on a website. Where do they go? What do they click? So it's not just limited to people. Structured observations. Must identify the observations in advance that you want to actually tick, and you can document them through notes, videos, or audio recordings or photographs. And the frequency of an event will basically determine your stats. Yeah, offers first-hand understanding. Because if I go to Sasha and I ask her, how many products do you consider before you chose this product in the supermarket or on the website? How many other products did you look at first? She's not going to be able to tell me. But if I observe her in the supermarket looking, she looks at, oh, this product, and then this, and then. And so you can count. She looked at 5 products, and then she went back to the one she first looked at and took it. And now she's buying a whole basket of products. So she did that 30 times. Would she be able to tell you that? No. But if you observed it, watched it, you would be able to see what she did. And then you could, you know, count. And that's a very objective form. So individuals do not necessarily possess the exact knowledge that, you know, they can't tell you, but if you observe them, you can find that out. Then document review, not really primary research, but if you do a systematic literature review, some people do journal articles on it, so you can do a systematic and see how many articles say this and that and that. So that's another way, pre-existing data. And we do a literature review. A literature review is basically a document review. You review the literature, and you could use that to publish a journal article itself. And then experiments, we don't really do this much in social sciences, where you manipulate several variables in a controlled environment. field experiments, lab experiments, quasi experiments. You have a treatment group and you have a control group, and you observe and record what they do, and you get them to do various things. And from there, you draw your conclusions. We don't do this in business, but if you go to the sciences, they do this. This is all they know how to do. In fact, I supervised a student from the consumer sciences program because they don't do quant. She did a survey. They only do experiments there. And yeah, and those are just the references. So that's the notes, but just now to practically demonstrate data collection, and I will show you just for example a few things. So let's just take this girl. So who's just finished. Yeah, go ahead.
Sorry, you indicated earlier in terms of designing the questionnaire that is one must always or try and use the questionnaire that has been tried and tested.
I'm going to show you what I mean now.
Yeah, and I mean, how easy to define such questionnaire?
Very easy. You don't take all the questions, you take the scales. So I'm going to show you that right now. Okay. So here's, for example, data collection. She created a Google form and she created a QR code. So she was collecting information in res, and she could just get people to scan this. Or she could just email people this code, or put it on social media or WhatsApp. She could send it to whoever. So whoever she got permission to collect data from. So that's an easy way to collect data. Let's just go to her questionnaire. So this is the typical format that I get my students. Oh, but what I wanted to do actually, before I even do that, let's just go to this Google. Let's just stick it in. Double click on this thing, it should take directly to it. So this is what it looked like in a Google form, and it's very easy to use a Google form. You can literally just figure it out. You go to your Gmail, you click Google Forms, and then you play it. And within half an hour, there's not much to click on. Or you just watch a few YouTube videos. So very important, I hereby give consent to participate in the study. So when you're collecting face-to-face, you can give them the informed consent form. Here you give it, and she should have actually made that a round box. I'm also going to say, if you don't click it, you can't submit. Okay? So, and likewise with the filter questions, we came to this conclusion. Do you have an Instagram account? She should actually not even have these no's here. Are you with me? It should just be yes. If they don't click yes, you can't go further. But what often is people say no, no, and then you get around and say, what types of advertising have you collect? And they click a whole bunch. So what does that mean? One, they've got Instagram, and two, they've seen advertisements. So they're contradicting. You don't capture the filter questions, but you do capture the data. So they can use the data because they contradicted themselves. So in this type of question is what's called a checklist. They can tick more than one option, and each one of these questions becomes a yes, no question. So if they tick this ad, then it means yes, they use it, or no, they don't. And I'll show you what the graph looks like later. It's not very useful. You can't really do cross tabulation or anything with it because it's a yes, no answer. But where this is useful is, say after she's done with the thesis and we publish an article, and now she wants to do an article just on collection ads. We can sort the data, and from those 500 responses, there's 300 that just use this, then we can write an article on this one. Then here's another, which categories do you consider? Right, fashion. So after the study, if she wants to now just write an article on fashion on Instagram advertising, we just sort the results according to fashion, and then we've got the data and we can redo the stats. Yes.
If we do it that way, how long is your data valid for? If, for example, if for those speakers and executives must be question, is it still valid?
You see, look here, cross-sectional data is the most is good. They collect in one point of time. So it's how you use it. Okay, I've had data that I collected 8 years previously, and I've used it. I've written and published a journal article. I just didn't mention ever when I collected it. That is the key. Technically, they say about 2 years or so. Okay, so I'm going to lose like 2/3 of the class now, but it's a good time.
Guys, Prof. Hemmonsby's, Doc Hemmonsby's here. So if anyone would like to do the poll later, come next door with us.
Easy too.
Yeah.
It's a good time. No, perfect. Other now before getting to the SPSS. This was fun. Yeah. But now we're getting into the real.
Thank you, Atlas.
Yeah, I need to get your addresses. You'll need to come give it to me afterwards. So after 12, give it to me.
Can I email you?
You can email me as well. That's fine. Then I'll.
It's also up on Blackboard, right? Okay,
It's fine. As long as I've left.
we will be here.
Yes, he was already with me, so he's already got it.
Okay.
He was getting duplicates.
Okay, sorry, Prof.
No problem. So that question, how long is data? I mean, there is no real fixed time, you know. But I mean, technically 2-3 years data is already getting old. You know, things have changed a lot. So, yeah. Yeah. And then others, how often do you use it? These are multiple choice questions. Everything's on Blackboard as well, so you can get it, but I mean, I can email stuff as well. Okay, good. So how often do you use it? Here you can tick one, and this would be interesting now to do cross tabulation. Once you've collected your data and you've collected the constructs, then you can say, well, is there a difference in terms of how people use Instagram that influences their intention to purchase? So, yeah. And so these are other multiple choice questions, and you tick them, tick them, tick them. Age, you capture demographics, and you go next. And then here's the Likert scale questions. And the questions were being asked, I think it was you or who asked the question about waiting, yes. So the other questions you can create, but when it comes to the Likert scale questions, you cannot just make them up. And in every journal article you see, they'll give you their statements. And then you can see what their validity and reliability was. And if they got good validity and reliability, you then adapt those questions to your topic, and then you use them. That's what I meant.
So you will find your questions to that topic that you're interested in from the journals and the other
Journals, number one source where you're going to find these constructs. And this is where we do most of the testing on the reliability and the validity. And if these questions are not right, you throw away your questionnaires.
Sorry, second question. At some point, somebody said you could ask if somebody did almost a similar study as yours.
Yes.
You could ask that person for their question.
Yes, you can use it, of course. But generally, you never use it exactly the same. Because then why are you doing the research? Unless they did it overseas or something. You would adapt it. And in South Africa, we've got a lot of unique situation, you know, demographics and a lot of things are different here. So you wouldn't use it exactly. You could use big chunks of it, but you adapt and tweak everything to yours. But of course you can, I get every day people emailing me, please send me your questionnaire for this study, that study. And I said, please feel free to adapt however you see fit. But you always adapt. It's very seldom that you're going to use the exact instrument. Okay, and then you have the Likert scales, and that's it. So that's a Google form. Just to show you what the questionnaire looks like. So this is what it looked like in a paper form. You know, and then people could just see how quick. If you give someone this, will take them 5 minutes to complete. And then you do these like these, that just tick. And 2 pages. All my master's students look like this. And this, let me show you the stats that this produces. And you're going to know how to do these stats by the end of today. That will be great. You're going to know how to do this by the end of the day. Let me just go to master student. Put them in there. Yep, the pipeline there. So this student I did a stats last week, I think. Takes me about 3 days to do one student stats. But then I don't just give them the raw data, I actually give them the chapter and they need to flesh it out. So I spoil my students. So you see, I give them notes and things like that, what to do. So this is what I give my students once, never mind my comments. So I give them instructions, so give an introduction. Each graph, you need to give a heading, the rationale, the graph, the figure, and the findings. And then I actually start, and I give it, I do the stats and I give it, so that checklist question, that's what your graph looks like. It looks pretty impressive, doesn't it? But there's actually very little you can do with this information, unless you want to do further articles later, because I can't do any cross tabulation. But if I want to then write an article on photo image ads, then I'm able to do that. So then I give her the graph, you give the rationale, you give the graph, you give the figure label, and then you write it up. And I even write up the first bit, but then I tell them to paraphrase it because I do this for all my students and I write the same way. But obviously, and then product category, so there's that graph. Also looks very impressive. And then frequency usage hours. So I've pretty much written this up for her, but she needs to rewrite it because all my students have similar type of questions, and then Turnitin will kill them. And then purchase incidents. So you have all the graphs. Whereas if you write in a journal article, all of this information would be one table. But in a thesis, you use graphs because you've got the space, you're not limited. So all your demographic, your usage question, and your Likert scale, you give graphs for them. Whereas in a journal article, it's just one table. I'll show you that later. And then your demographics, your gender. So all of this, you'll know how to do after today. Very easy this to do. My second year students do this as well. So it's very easy to do. Then consumer attitude. So you give the means. She had 7 constructs. I'll show you how to compute the means and standard deviations. And then you give the graph. So she had 4 Likert scale questions, but you need to condense them into 1. So for each, for measuring entertainment, it says 4 Likert scales were used to compute the weighted average. So you need to take those 4 Likert scale questions, calculate the average for strongly agree, disagree, and then give 1 graph. I'll show you how to do that today. So, because often I get theses to mark and then they've given each Likert scale as a separate graph. It's meaningless, it means nothing. You can give that in a certain table, the means, but not graphs. I mean, that's pointless. You need to combine it into 1 graph. So the entertainment credibility. So write up the first few and then I tell it to write up the rest. And then I do factor analysis, which we're going to do today as well. I'll do factor analysis. So now you need to check. You have 7 variables. Does this show that you have 7 variables? And this eigenvalues, I'll show you how to do this today as well. If there's 6 values, then there's a problem. If you have 7 construct, then we need to fix that. But those stats worked out okay. Then I'll show you the screen plots as well. We'll cover that today. So between 7 and 8, there was a kink, which means you can use the first 7 constructs. Do that today. We do the pattern matrix as well. This is the factor loadings to show that these 4 variables belong together. These 4 variables belong together. They all need to be above 0.5. So hers worked out beautifully. I'll show you how to do this. Reliability and validity. This tells me whether I can use your data or I can't use your data, whether I'm going to chuck it away or not. So here you can get the means and standard deviations for each. The factor loadings come from this above. the average factor loadings and average variance experience, average variance extracted are your convergent validity. So these all need to be above 0.5. I'll show you how to do that. Your two reliability measurements, composite reliability and combo alpha, all need to be above 0.7. I'll show you how to get to that today. And then you also need to do discriminant validity, which is taking the square root of these AVE values, and they need to be bigger than the component correlation values, which I'll show you how to get. And then she also did an HEMT, but I won't do that with you. That's not necessary. It's also discriminant. Then structural equation modeling you won't do, but I'll show you how to do regression, which will give you the same values. I won't cover multicollinarity stats, but it's very easy to do. And then this is a model. This is masters. This is what a model looks like. And this is impressive. So this is what her model looks like. You will learn all the stats to do most of this today. You just won't do mediation. But all of this rest, these standardized beta values, you get them from regression. I'll show you how to do this. Okay? And then you have your hypothesis, which you can test via regression. And then the generalized linear model, there's also t-test and ANOVA. So now we've cost calculated usage hours, frequency, length, gender, age versus intention to purchase. And then we got the results saying what the differences were. Here we found that people that spent less than half an hour using Instagram build less favorable purchase intention than those who spent longer periods. That makes sense, that finding. Usage length, people that have been using Instagram for less years were more positive in terms of purchase intention than people that use more years. That makes sense. People who use it for more years are more experienced, so they dodge the advertisements more than people who are not experienced. And purchase incidents, okay, people who rarely purchased obviously were less positive than those people who sometimes often have. So you see the findings, they're interesting findings. So at the end of the day, you should be able to do this chapter. And if I see a chapter like this from a thesis, I'm happy. But I never do. Only my students do this. Whenever I'm on theses, I go home, I'll work. That's because most supervisors, unfortunately, are not able to do the stats themselves. And it's only if the supervisor can understand and does the stats themselves, can you guide their students correctly to get the results. But 90% of supervisors are not able to do this themselves. And therefore, when I see a topic, I should be able to, just the topic, I should be able to see the study from beginning till the finish already. And then as soon as I got the topic, I say, design the questionnaire. Research questions, give me that, but design the question first, give me the conceptual model. Once you've got that, you can finish the whole thing. Because, in getting a topic, you need to have read. In my opinion, my students need to have read 100 journal articles already and summarize them on that topic. Then you'll know exactly what you're doing. And 100 is just the beginning. If you look at my master's students, on average, they have 600 to 800 sources in their reference list. Masters, not doctorate. Okay? So reading is the key. You've read 100 and summarized, and it sounds like a lot, but is it a lot? If you summarize and read 2 journal articles a day, how long is it going to take you to get to 100? 50 days, under 2 months. 2 journal articles a day to read and summarize. A couple of hours a day, 3-4 hours a day. For under 2 months, you have 100, and then you'll know exactly what your topic is about. But that's a different lecture, a different topic. So I'm very demanding with my students. I expect a lot of them, but then I give them this. I give them a lot. So that is, right. So that's just to show you what we are heading towards. Are you still alive? Do you want a little break, or are you ready for SPSS?
It's a push through.
Yeah.
Okay. Well, this is my passion, my exciting, the numbers, the analysis, yes.
So before we get to SPSS, I thought, you say you're doing that, all those results, stuff. And the students inputting that information into whatever computer program that they're using, and it spills out.
Not the way I'm giving it to you. You get raw data. So the raw data, if I just quickly go there, it doesn't come out like that. But you see, I give them all my old theses from other students that have already done it. So then I just say, read what they've written, find your own sources. So once you've read two theses using exactly the same format, then they understand and they can then write their own data. So her raw stats, if I just go into stats, raw stats. So, you get, so if you look at the collinearity, this is how it comes out. It comes out like this, and you need to know what to extract. And if I show you, the descriptives comes out fine. So descriptives give you the means and standard deviations, but you need to put them then in those bigger tables. So if you've got a template, so that's what I'm giving them, a template, and I just want to take this information and put it there for them already, because it's not much work, because then when I do the next student, I just take her chapter and I just switch the data and the questions, for them. So it's not too much work for me either. And then I give them all the other theses that are finished and say, okay, they followed exactly the same format, although your content is different, the tests are the same. And so based on what they've written, you understand, then you've got to go and read journal articles and textbooks and write the theoretical aspect yourself and then practically apply it. Well, I've done the practical application, you just need to rewrite it. See? So that's what it comes out. So let's go to, unfortunately, it doesn't come out very big on the screen, but I'll get your email addresses afterwards and I'll email you the video. And it's also on Blackboard. I'll put it on Blackboard as well. But if you don't have access to Blackboard, I'll retransfer it to you. Because I can only retransfer to 3 people at a time. So I had 6, so it was just 2 retransfers. So there's 4 of you, so I'll do 2 and 2. I'll send you the video afterwards. Okay. Quantitative data analysis. I just updated this morning. And I need to open this. And I'm going to send you this SPSS sheet as well that I'm working from. So with the notes, you have my notes, which give you step by step what to do, and you have the SPSS sheet. So if you want to practice the calculations and see if you come to the same results, you can do that. So I'll actually send you the SPSS worksheet. I won't send you the questionnaire or this or that, because all of it's in SPSS. You'll see. So I will send you the SPSS sheet, and you can then, if you've got SPSS, that is, you can then from the notes, I give you step by step, you can practice, and then you can put in your own data and play. If you've collected your data already. So that will just take a little while to open. But while that opens, let's go to the real fun part. I'll send you these notes, but I won't look at them that much because I'll be just showing you, rather than, and you can follow the notes afterwards. Okay, this is SPSS. Open, is it open? Okay, good. Unfortunately, this I can't make any bigger. If I control, it doesn't get bigger, but that's why I said the video is great. You'll be able to see that afterwards. That's perfect in the video. So the fundamentals of SPSS for quantitative data analysis. So basically just my philosophy is that you learn the different statistics to answer the questions at hand. So as your questions and problem arise, so you learn. And for me, like I started a long time, I used to sit with Dr. Corey Ace in our office for about 5 years, and I'd go there every second week. And as I did articles, I'll sit with it for an hour and we'll just play stats. And then after that, then YouTube. And a brilliant guy is Prof. James Gaskin. He's a statistical guru. He's got a YouTube channel and he's got a website, StatWiki. You'll get this in the notes. Go and watch his videos if you want to learn specific tests. This is your man. He's really, really, really good. If you just Google him, everything will come up as well. He's really good. And there are 800-page textbooks and whatnot. But my point is I only learn the tests I need to do at hand. So as my students come with different problems, they challenge me and sometimes I don't know how to do something. And then I've got to learn, I've got to teach myself, I've got to ask other people, I've got to watch YouTube videos. I've got 2 statistical books, I've got Field and Valant, old books, and I go in there and see if I can learn how to do it. So basically I do the same thing over and over for my students because the formula works and it's the standard. The stats we're doing, you'll see in every journal article. Okay. So I've given 3 questions. This was a master's student from a few years back. And so she was looking at social media and marketing communication amongst Cape Town tourist attractions, specifically in terms of cognitive attitudes. So cognitive is your awareness and knowledge, your affective attitudes, which is liking and preference, and your behavioral responses, intention to purchase and purchase. And then she looked at various geographic, social media usage factors and demographic factors, which we'll use for cross-tabulation, right? So her research questions, here they are. So what influence does region have? How do on the different attitudes? So we do cross-tabulation. How do tourist attitudes differ across different attractions? Is there significant difference? What influence do social media variables have? And what influence do demographic variables have? So these are all cross-tabulation, which will use a t-test, ANOVA, and a generalized linear model to compare differences. And then she had 3 hypotheses. And here they are. Cognitive attitudes has a positive influence on affective attitudes. Cognitive attitudes has an influence on behavioral attitudes. Affective attitudes have on behavioral. So you saw that big diagram I showed you. You can have a big diagram like that. Or this is just a small one for the example. But you can test each of these through regression. Linear regression, very simple test, very easy to do. You don't have to do structural equation modeling. Regression is also good enough as well. In fact, my whole doctoral thesis, I had no regression and no structural equation modeling. I just looked at the cross-tabulations, you know. So questionnaire cleaning. So once you've designed your questionnaire, so let's just open a questionnaire. Bigger. Here's a questionnaire. So very simple. Here they put which region do you reside in? Which tourist attraction have you been exposed to the most in terms of social media? What social media do you use? Okay, this was a few years back, so there's no TikTok or Instagram at that time, wasn't popular. Please indicate whether you agree and disagree. So the first 6 questions was cognitive, the next 6 affective, and the next 6 behavioral, and then how do you mostly access, how often do you engage, your age, your gender, different groups, right? So that's just a simple questionnaire. So you can see it was very similar to that other girl's questionnaire I showed you, except hers was just much bigger. But it's not the full questionnaire. I've just extracted bits and pieces, but it's good enough for masters. It is good enough, but this is, there's more to it than this. There's actually a 2-page questionnaire, but I don't want to, you know, I just took what I needed to use. So, right, so the first step is to check the questionnaires that there's no missing data. If you collected it by Google Forms, that's easy because you don't let them submit if they haven't ticked all the boxes. You set up round multiple choice questions. If there's one question they have not clicked, you can't go to the next page. So that cuts that off. But if it's manual data collection, it is possible that they've missed questionnaires. And so you need to check, and there are ways to fix that. Okay, fix that missing data. You know, like if you went to a high school and they didn't fill in their age, and you know it was a grade 9 class, and the person before was 17 years old, the person after, what age are they? 17. So you can, and if they don't fill in a Likert scale question, then that's simple. You just make it neutral. So it doesn't count for, and SPSS also has a factor, but it really messes up your stats if you have missing data. So you check if there's a questionnaire, there are too many things missing, throw it away, survey someone else. Okay, you can't have any missing data, ideally. Okay, very important. So electronic data collection circumvents that. Secondly, code all the questionnaires. So coding is very, very simple. So to code it, in SPSS, you're basically just going to cut and paste a whole bunch of numbers, which I'll show you when we capture. So for question 1, you have questionnaire 1, which region do you reside? So South Africa's 1, Africa's 2, international 3. So when you capture this, you're not going to capture South Africa. If they tick South Africa, you're going to capture 1. You capture everything by numbers. Okay. Which tourist selection have you been exposed to? Again, 1, 2, 3, 4. And that's how it goes. 3, 1, 2, 3, 4. The Likert scale questions, you had 4, 1, 2, 3, 4. You capture those numbers. And I usually send my students an SPSS sheet. And I wonder if I've got that example here. Data capturing example. There we go. So this is what it looks like. You see, you just take each question, you put in the column here, each question, and then you capture each question by 1 number. That's it. So in the region, and you capture them left to right. So if they said the region was 1, so if we just putting in this questionnaire, how would we capture it? They just delete this. You always put questionnaire 1. So now, if you go to the first answer, and so just what I do is often I do this. This is the easiest way to capture. If to show you, I just go here and minimize this and make it smaller. So you know you can do stuff like this. So then you go, so let's just say they say South Africa, then you know for this questionnaire 1, you say 1. What did you use? Where did you go to? We went to, let's just say Kirstenbosch. Let's just say Cape Point. So that would be captured by a 4. What social media you used? Facebook. And then what did you do? Let's just say they said we agree, we agree, we agree, we agree. We neutral, neutral, neutral. We strongly agree, strongly agree, strongly agree. We that's agree at least, strongly agree, disagree, disagree, disagree. You see, it's codes. And so you capture each questionnaire left to right. However, if you've collected it from Google Forms, it makes it much easier. I don't think I showed them this one. And so you'll capture each questionnaire. Just go undo. I don't want to close this yet. If it's selected from Google Forms, let's just go to, say, one of my advanced diploma students. I already get them to collect data. And then your Google Forms output looks like this, right? So this is what your Google Forms output looks like. Now you need to convert this to numbers. It is so easy. So if you collect it electronically, and now instead of having to capture it physically, if you did hard copies, all you do is this: find, replace. So now you want to replace strongly, this, agree, and you want to replace it with 1. Replace all. 5.
And how you do your.
Yep. Now you go disagree, and we make it a 2, and we go replace all, and we go neutral. Now this would take you days to capture.
Okay, so, yeah, so what, but don't you then, even though like you got your
Now you can't,
spreadsheet or your questionnaire or survey, haven't you then manually had to save that?
no, if you collect it via Google Forms.
No, Google Form, obviously.
If you manually, then you've got to do what I showed you. You have to capture one by one. But you capture the numbers, right?
Yes, okay, cool.
But if you use the Google Form, how many of my students use physical questionnaires anymore?
Okay,
They go with their phone instead of a piece of paper. Why make double work for you? Let people fill in on your phone or your device or your tablet, fill it in. It's saving you days of boring, back-breaking work where there will be mistakes because people don't fill it in properly on paper. Whereas on Google Forms, you can totally cut out all of those mistakes by making multiple choice questions with round dots. So the grid questions allow more than one response. That's where problems can keep in. But the grid multiple choice questions, you always state when you set up the Google Form, must complete question, must complete it. So if they don't complete questionnaires, they can't submit. So all the questionnaires you're going to get from via Google Forms will be fully complete. And now you just do this, place off, we've done that already.
and Prof, like, and some of the big databases I've worked on, because sometimes it may be with your supervisor or someone else working on that database, etc. We always have another tab at the bottom, and that has like the coding.
Yes, yeah.
Yeah, so that if, like what he's doing now, so on that first tab, he'll say,
Yeah, well, this is,
question one, where the people all live. South Africa will be one, Namibia two, Botswana three. So someone that's not familiar with the actual database, they go and have a look at the spreadsheet, they will understand the coding.
yeah, you can have an extra tab, but I
Yeah.
always send my students I always send them this. I take the questionnaire and I just insert the codes.
Okay. No, but you're very kind.
Here's the thing.
Kind. Lots of supervisors. Do that.
It comes at a big price because I push my students. Push my students. So you see what I'm doing there? But now you can't do agree before, you can't say agree first and put the code in because then it's going to change the strongly agree to 4 as well. So I first do strongly agree 5 and then I do agree afterwards. You see what I'm doing? Because if I said agree first, it would change it to strongly 4.
Oh, got you.
So now I put agree after, I first do strongly agree and then I put in the 4. Look at that, all done. In 2 minutes. And then you can do the same, except for these grid questions. Okay. All of these others, male, female, if they don't fill in like 21 years, 2 years, it's easy to fix that afterwards. But this grid question, remember, they could click in multiple options, right? And this, which platforms they could tick, those you're going to have to manually catch. But all I do is I do what you say, I minimize it, I open it up like this. And then I open up the data capturing sheet like this, and then I can see, and then I can fill in, 1, 1, 1, 1. And just for a grid question, not that sheet, this is a different study, but just to show you, like say this was a grid question, and let's just delete this. And let's just say we're catching WhatsApp, YouTube, or whatever. And so it's yes, no. So yes, 1, no. So you only need to capture the yeses. So let's just say you use, let's just say this was Facebook. Never mind about this. Let's just say that was Facebook. Let's just say these were the responses that they ticked yes for, right? So you only capture the yeses, right? Like this. Let's just say that 18 social media options. Now, when you finish capturing each question, you have to capture each one. You just block it afterwards. I'm just going to close this now. Don't save. Open. Bigger. So you've captured all the yeses. That's that grid question where they can tick more than 1. And then these are the ones that they tick yes for. You just go find and replace, find and replace. and you go replace, and you just leave that top one blank, and then you fill in the nose with 2, go replace all, and it fills in all the 2s.
Yeah.
Another shortcut. You just capture the yeses for each question there. Once you're done with that, for those 2 questions, the other example, and you just do that or your nose. So you just capture the ones. Also save you heaps of time, because that you can't split into the columns, because each column, Facebook's a column, Instagram's a column, TikTok's a column, because it's yes or no, and they can tick more than one option. So yeah, so that's another tip. So once you've captured all the data, all the way back, then you need to check for errors. Let's just see where we are in this notes code, right? Lastly, number, data capturing, we've covered. Check that there's no gaps. So if you manually capture the data, now you need to check that there's no problems, because any code that you have not computed into SPSS that is different is going to give you an error. Either it's missing or it's going to give you the number. So, right, let's just make a few mistakes here. So let's just make this bigger, and let's just say for region you typed 11 year, and you typed 33 year, and you had nothing year and nothing year, and you typed 11 year and 11 year, and you had a gap as well. Right. Once you've done capturing the data, this then gets cut and pasted into SPSS. But to find these errors, you know that for region it can only be 1, 2, or 3. If it's any different number, SPSS is going to give you an error. You know, for Cape Town tourist attractions, it can be 1, 2, 3, 4, 5, or 6. And we know for social media, it can either be 1, 2, 3, or 4. Any different number is a problem. So I always tell my students, after you're done with the data capturing, just go sort. And then I say sort A to Z, and now you scroll to the end. And now you can see, oh, questionnaire 1, I've got 11. Oh, that should be 1. Questionnaire 4, I've got 33. That should be 3. Then we do the same for the next one. You just go sort A to Z, scroll to the bottom, and see, oh, there's 2 gaps. Then you can see that's in questionnaire 1 and 4. You would have numbered the questionnaires on Google Forms. They're in that order. I always number when I get Google Form, insert a column, put 1 to 400. Because you want to keep that order the same, and you want to keep those responses for questionnaire 1 always in questionnaire 1. You don't want to mix it up. So never block a column and then say sort, because then it's only going to sort that column and take it out of sync with the questionnaires. Never block it, you just put it that way. So then you go and check in questionnaire 1 and 2, what's the problems? Oh, that should be a 3, that should be a 2, or whatever the case may be. And that's how you fix it. But let's just, right, then once you're done with this, then you copy and paste it into SPSS. But before you can copy and paste it into SPSS, you need to set up SPSS. You're going to get a blank sheet. So this is what SPSS looks like. So this, each question is captured by a line. Yeah. Like, yeah, each question. So I just want to get back to this SPSS. So there's 2 tabs in SPSS. There's the data view tab. This is where you put the data. And there's a variable view. This is where you program SPSS so that you can copy and paste your data from the Excel sheet in. Right. So there's firstly the name. Okay, so even before you start, just if you go to edit and you go to options, and then you go to output, generally I like names and labels and labels, names and labels and labels. Just how it's going to output the data. And I'll put that in the notes, but it's up to you what that looks like. So firstly, I type in quest num, actually, numerical 11, label none, values none. In other words, that's so that quest num is so that I can put in the order of the questionnaires. Okay, or some people call it ID. It's very important to have that column, because it allows you to sorts the data. Okay, so before I go, let's just go through the various labels. So the name, you choose a descriptive name. The next column, you pick the type. There's no spaces, by the way, in this name. So if we go back here to data view, variable view, there's no spaces in this column. Okay, no space. You give a space, it will give an error. So there's no spaces. The next column is it's always numerical for you, unless, but let's just go to the notes. Generally, type numerical for quantitative data, string if you're covering qualitative. If you've got open-ended questions, you call it string. Okay. However, I recommend that you only use closed-ended, don't use open-ended. With the next column, standard is 11. Decimals, I generally use naught. Label, copy and paste each question from the questionnaire. So let's just go back here to the different columns. So this is always new. This is 11. This is the label from the questionnaire. So here you actually copy and paste in each question in. And literally, you know, if you go to the questionnaire, you just open the questionnaire. Open the questionnaire. So to get the questionnaire like this is easy. You just do this. Just go copy, go into SPSS, and then you just let's go from top to bottom. One, two, back. There you go. You right click and you go paste. There you are. It's the same. There you go. End. You see? So that you input the question. So this is simple. You just give a short abbreviation title, numerical 11 with the question. Next column is the values. Now you need to program.
But what's the width again with that 11? The top there? Sorry, there.
With 11.
What's that?
You just make it 11. You can make it 8. That's how wide the column is.
Oh, right. Okay, cool. Okay, cool.
Yeah.
Okay.
Decimals I always make naught because in any event it's going to come out to 2. If you have 2 decimals and it gives you 2 decimals, it's then going to make it 4 decimals. So I always just change it to naught. The label is your questions. You just copy and paste them in. Now the values is the one that's the first little bit of programming you need to do. So there's 3 little dots there, you click it, and there you can see our program in question 1. 1 equals SA, 2 equals Africa, 3 equals international. And how you do it is you just push the plus button, and let's just say we had 4, and we had other, and then you just go plus. And if you want to delete something, you just block it and just go.
Even though you've set this up in your Excel spreadsheet, etc., you still have to
You now need to code it.
SPSS.
Yeah, but I haven't, the SPSS, I mean, this is not setting it up. This is just a quick way to capture. It's easier to capture in Excel than it is in SPSS directly.
I wouldn't suggest that at all, but
because it's very hard to sort and play around once it's in SPSS. So I always give my students this.
wow.
No, I create, because I just take, all I give them is,
Let's do it.
no, I just do this. I just do this. Yeah, I give them that, and I just
That's
give,
still very kind.
no, but how long does it take me to do this? And then if the student does it, then now all of a sudden he leaves out a question. Then when I do the statistical analysis, I'm close. So if I give it to them,
Very kind.
if I give it to them, then there can be no mistakes. Because this doesn't take any understanding to do this. But if they mess it up, then it's going to, at the end of the day, cost me more time doing their stats, because I'm the one that's doing their stats. So I want them to get it right, and if there's problems with this, I just send it back and say, please fix.
You
Yes.
sit with them though, and also do the stats at some point?
Okay, yeah, no, I go through it, but I've usually taught them at fourth year.
Okay.
And we've done 70% of this already at fourth year.
Okay. Okay.
But you do get students that dodge me at fourth year. So then
So you have to go back and code in the actual SPSS with it?
you don't code, you're just gonna cut and paste this in. Oh, yeah, you're gonna program it, yeah.
Yeah, that's what I mean, sorry.
Yes.
Program.
Question?
So,
Carry on.
with your PhD students, do you do the same thing with them?
Yeah, same. Doesn't make a difference.
I thought we're all gonna go with.
Can I have your student?
I also wanted to eat.
But remember, there's a price, I've made you
That's
guys
work,
read
make you work hard.
hundreds of articles, this and
I'd
that.
rather that.
I'd really push. I help them with the stats. But that's just one little part,
Yes.
really. You can get any statistician will give you the raw output and you put it there. It's just the stats, because I know if this section is right, everything else, they can't fail the student. They can't fail the student because the stats is right.
This question is to Sasha. Sasha, when the committee, decides on the supervisors for students, after submitting the topic, as said, the supervisor needs to look at the topic and say, this is what, this is, so when you choose the supervisor for students, the committee chooses according to the strength of the supervisor.
Yeah. They will probably choose according to their expertise.
Yeah.
You're gonna take, Prof. Duffett's department is quite strict in terms of how they choose their students. And
We choose our own students.
Prof. Duffett will never take a student if it's outside his area of expertise. There's no point. Whereas other departments, they're trying to get their numbers, and so they take on students and then they kind of just distribute them amongst.
It's different from different departments.
Yeah.
My question is, where are you now sitting, you doing your stats and your supervisor looking at you like, and you looking at him like. Because the stats is messing it. Yeah. Both of you are confused about numbers.
Anyway, you need to get help.
Yeah, then you need to get help.
You need to get help. You're going to speak to a Corey Ace or something.
Yeah. That's what I did for my master's, and I consulted with.
She's amazing.
Fan of Professor Bina.
Unfortunately, Corey is not actually,
Yeah, officially there's
no, not anymore. She's actually been contracted to, I think,
other
Faculty of
faculties.
Education. Yeah.
Anyway, we've got to move on. We
Yeah.
have really lots of analysis. We've got an hour left, and if I go over, it's because you guys are talking too much. So you code each 1 equals this, 2 equals this, 3 equals that. You code each question in here, right? Once you've coded and you can copy things as well, right? So if you program this one, strongly disagree, agree, and agree in, you can just copy it then. You can go copy, and then you can copy it here and go paste. You see? So you just paste it in. It's simple. The missing variables, I always say none. Okay, I don't accept any missing variables. Okay, then a line is always right. Nominal ordinal, this is, okay, so let's just look at that in the notes. Okay, we close that current tab. So if we look at the measure nominal, the questions do not have rank. So gender, there's no ascending order. So then you would label it nominal. Ordinal is if the questions have rank, a Likert scale, strongly disagree, neutral, agree, strongly agree. Scale is when there's distinct matrix, like a class mark, okay? There's rank, 100% versus 50%. You would use that. And then, So then you program that, and that you just select, gives you three options, scale, ordinal, or nominal. And then roll input. So that's how you program it, and you program question by question. You program it. Once you've done that, if you go to the data view, each question then gives you a column. And now you're ready. Once you've got that, then you just take all this data and let me just make a few mistakes here quickly. 44, 11. Yeah. You cut and paste it in. So let's just cut and paste these 8 questions in here. You got that. Right. So now your data's in. Right, just I showed you data view, the difference. One shows the data. Now we're looking at statistical measures. So the things that I start off with, I'm not going to go through these notes, I'm just going to show you. Okay, that would be the easiest. Is I start off with descriptive stats and I start off with frequencies, and this is where you can make your graphs from. All those graphs you make from here. So that's, and I do this to see if there's missing data or errors in the SPSS. So all you do is you go into SPSS, you go analyze, you go descriptive stats, you go frequency. Now you drag across everything. You just put your cursor there, you push control and the down pull. Oh, I don't know why. Come on. There we go. Control and the down arrow, but I want all of that. Another one here. And that's nice. Why doesn't want to block them all? What's wrong with the applied energy? I'll just do it manually. So you just block them. Have your finger on control. Shift them across there and just click OK. Now it gives you, firstly, this top line shows you anything's missing, and there it says 3 missing. That's a problem. So now you scroll down and look at each one. Which region do you reside in? You see SA Africa International, 11. Was there a code for 11? No. So there's a mistake. You see? So now you've got to go back and find which questionnaire it was and fix that mistake. Here it's got a 44 and it's showing 3 missing. You need to go and find those errors and fix it. So I just do frequencies, and so you scroll down to see if it's all kosher. Let's just go undo. Right, good. But once it's all fixed, we just go analyze, descriptive stats, frequency, and we go okay. And here's all your stats beautifully, right? Then to export the stats, you just go File, Export. I always export as a Excel spreadsheet. You never export into Word or anything else. Excel is always the best. And then, okay, research workshops frequency. You type in your name, so browse. Here we're into stats. Let's just browse somewhere. Oh, but it's going to go straight in here already. I've already coded a frequency, and then we'll just go okay. And it exports it. Right, and then I go into, I think I exported it to research workshops. Here it is, frequency. So now you've got your stats and all this gobbledygook, and this, I delete all of this because you don't need it. It's just all the admin part, delete. And now you've got all your stats, frequencies, percentages, valid, cumulative percentage. Usually, you don't, if you need the frequencies, keep it, but usually for my students, I delete these 2 columns, I delete the cumulative percentage, and now we're ready for graphs. Block it, insert, recommended charts. Let's say we want to apply charts. Okay. Delete the chart title because you're going to put your own figure in, add data, financial profit. So you've got all of this now ready. The Likert scale questions are different though. Usually I write code. So remember, you've got 6 cognitive questions, right? But you don't want to give 6 graphs for each individual statement, means nothing. You need to combine it. So so what I do is, here they start. So I just see what's the first number here. It's C38. So I say equal C38. And then I just drag that down. So it picks up the rest. You see, just want to close this here. So it takes it up. And then I go to the next one. This is, so it's every 8 equals C46 equals C46. So it takes that 2.3 and it moves it up there. And I drag it down. So if it's every 8 and there's 6 statements, so this is, and so this is 38, this is 46. So the next one must be equal C54. Next one must be equal C62. And there's 6. The next one must be equals C70. You just see if 70 is 1. Yep. So it is equal C70. And now I just drag all of this down to get the rest of the data. Right. And then what we do is we want to get the average of these 6 statements. So I just say equals sum block all of these. Close bracket, divide by 6 equals. So that's the average for the 6. Drag that down. Format cell, we want to go to format cells. We want to make it numerical and we want to make it 1 decimal place there. And make that bold. So there you've got your average. Make it bigger of the 6 statements. Now you want to create that one graph. I just copy this across. Make that wider. And then I take these numbers and I go copy. I copy them as a number only, not the formula as a value. Just have to go format and make format cells, make it again number 1. Okay. Make it bold. And now you're ready for your Likert scale, your weighted average graph, which I showed you. We just go insert, charts, recommended charts. Okay. Delete the chart title, right click, add data labels, and there's your cognitive weighted average graph. And once you got this formula, you can literally cut and paste that formula down for the others and it just creates your graphs quickly. Okay. So this will allow you to create all those graphs I showed you in the chapters. Done. Okay.
Are you quite happy with Excel, the Excel graphs and stuff for your students?
Perfectly. Depends what version you have. Obviously, the later version you can play. You can use other programs. It's really, actually, the graphs is just to make it look pretty. It's really meaningless. Because all of this information you could just put in one table, like you will do.
Yeah, sure.
So yeah, I'm quite happy with Excel graphs. I've never ever seen anything else actually.
Have you ever used
I've examined,
Prism?
but I've examined like about 40 pieces. I don't think I've ever seen anything other than Excel. It really is. It doesn't count for anything, in my opinion. This is just making it look pretty, filling space. Graphs mean nothing. They are meaningless. It's when you get to the actual.
Oh, that's very. I mean,
They're just giving you frequencies. They're just giving you frequencies. So you have 200 women and 200 men. What's it mean?
Not that, yeah. Okay.
So people, okay, use social media multiple times a day. We know that before we've even done you know the answers to most of it.
Yeah.
You should know the answers. If you don't, then you haven't read widely enough.
Yeah, okay. Like we often use graphs and stuff.
Yeah,
The health. Yeah.
in a presentation, you can use pretty graphs. A graph's a graph. I mean, you can have a Ferrari or you can have a a 3-to-3 rust bucket. They're both going to get you from A to B.
Yeah, but it's the visual presentation.
So there's nothing wrong with Excel. What you got against?
No, I'm just saying, are you, because I can't get our pay more, so I'm asking.
I'm
You're
totally,
okay,
I've never,
okay with
I've
it.
never seen anything else other than Excel. If you're doing a professional presentation to the presidents of the country, yeah, maybe you want to get a fancier graph, but at the end of the day, it's going to communicate the same information. That's my personal opinion. Right, so we can close this. So that's the first little step. And this is, I mean, my second year students do this. Okay, these graphs, I get them really. When I taught second year, they did the same thing. So we can close that. Let's go to the next. So frequencies, export, I'll show you how to do this. The next is descriptives. So we want to get the mean and the standard deviations of each Likert scale, because I'll show you in this diagram, you're going to see this. You see this table here? Every single journal article you read that does quantitative stats, you're going to see should see a table like this. They're going to give you the scales, the mean, the standard deviation, the factor loading, the average variance experience, the composite reliability, and Cromberg alpha. Every quantitative study that does a survey, not everyone, most of you should see this table like this.
But what is factor loading?
It's from the factor analysis. It's a convergent validity we're going to get. So what I'm going to show you how to compute all these factors. So when I mark theses, I seldomly see this table. Then I know there's data missing because I don't know what validity is. I didn't know what validity was when I did my doctorate. There was no validity measures in my doctoral thesis. And it took me a long time to work out and self-teach and find out what all these measures were. Now, at least my students get it on a silver platter. They know what it is and it's there. So too often people just give me mean, standard deviation, sometimes factor loading, sometimes Cromberg alpha. They're missing the ABEs, they're missing the composite reliabilities, and then they're missing this figure below, the discriminant validity figure here. They're missing this little figure as well. Too often. And then I say, no validity measures given. The cum laude possibilities are gone there because they weren't guided. So we are going to calculate in this table the mean and standard deviations. Okay, so let's go to this. T-test, what grades group reliability. So we need to calculate the means and standard deviations of your Likert scale items. So how do you do this? Also very simply, you go analyze, descriptive stats, descriptives, right? Then under options, you want to take away the minimum and maximum, and you just want mean and standard deviation. That is all in the notes as well. Continue. Now we want to take our 18 constructs. Now you see it's copied. I don't know why you took control, down arrow, and you take it across and you go OK. And there you go. There's all your means and descriptives for each variable so that you can include it in that table. Okay. So that's very simple. But what do these individual, a construct for why is a scale? So cognitive, we've got 6 individual items. So these 6 items all measure people's knowledge and awareness of social media. The 6 affective statements all measure liking and preference, and the 6 behavioral elements all measure intent to purchase and purchase, right? So we group those 6 together. But what do they mean individually? Nothing. We need to group them together. Okay. So there are 2 ways to do it. I'm going to show you the one way. So this we've got for the table. So how to group variables in Excel together in SPSS at least. So let's just do reliability afterwards. Let's first create the group. No, let's first do reliability. Sorry. So reliability measures is a scale that if you administer twice will produce the same results. Okay, so if I give Sasha this questionnaire and she fills it in one time, and then I give it to her 2 days later and she fills it in again, it should produce the same results. That is what reliability is. There's two measures to do it. The first measure I'll show you now is Comberg's alpha. So to do this in SPS, and the values for Comberg alpha should be above 0.7. So, which is also all in the notes as well. So I go analyze, I go scale, and then I go reliability analysis. Everything is in this analyze. I go reliability analysis. So under items, I take the 6 cognitive Liggett scales and I put under items. And under name, I type in cognitive. Under statistics, we want to just check if we've got the best reliability that we can get. So I click scale with item deleted, but you don't have to do that, but it's advisable. And then you go continue and you go okay. So now it shows me, sorry, I can't make this bigger, that the Comberg alpha is 862, which means it's above 0.7, which means the stats are very reliable. And but if you look here, it gives you a score. If I deleted this variable and only did it on the 5, then it says the score would be 847. If I deleted the second item, the score would be 840. So it shows you, if I deleted the last item, the score would be 854. So you can see this is higher than all of them. So we've got the best possible fit. But say this at 9.5, if I deleted, say, item 3. Then I would strongly consider deleting that item because it would improve the reliability majorly.
If you get under 0.7, then how do you rectify?
Well, you would firstly look and see if I deleted one of the items, would it improve? Some people, then you're going to have to find, say it was in the 0.6s, then you're going to have to look for very specific literature. And you will find some literature that says 0.6 is also okay. That's what you'd have to do. But if all your variables were under 0.6, for all of them, throw away the data. Can't use it. Done for. I've had students like that. But reliability is not the only test. Validity is even more important. So you need to look at both reliability and validity. So I wouldn't delete the statement if it said that you were going to get 0.5. I'd first have a look at the validity. And then I'll decide, okay, if I delete it, what happens to the validity? The validity may decrease if I delete it. So you've got to look at both before you make that decision. So that's what you do. All you're after is this one number. And if we go back to this table at the end here, you will insert that one number here, 862, under the Comberg alpha column. And then you do the same for effective. And so that's how simple it is. So let's go to the next step now. As I was saying, we want to combine the 6 cognitive statements into one. So not creating it, but we want to actually get one mean value for the 6 statements. And you do this by creating a group. So how do you do this? Now you're going to actually click something different. Just close this. Now we're going to click something different in SPSS. We're going to go to transform. Okay, we're going to click compute variable. It is all in the notes. Then under function group, we're going to double click on statistical. And then under this function and special character, we're going to double click on mean. Right, now we're ready. So in the target group, we type cognitive. And these 2 question marks, you can just delete them and just leave the 2 brackets. Then you double click on cognitive. You see it's put in its end. You double click on cog2, comma, double click on that, comma, double click, comma, double click, comma. So it's going to take the mean of these 6 respondents. For each respondent, it's going to calculate the mean of these 6 statements. So I'll show you what I mean. So I click OK. Cool. Okay, we'll just, you go okay, and I won't actually run it. And when I click okay, because I've already done the actual calculation, you'll see under variable view, it's created a new variable called cognitive. And you must then change the decimal. It will usually show 2 decimals, right? So you change that to 0 decimals, don't 1 4. And it creates a new, and it's now called a scale. And if we go to the actual data view, you'll see it's taken the 6 cognitive variables and calculated 1 average for it, for each respondent. So it's taken the 6 cognitive statements, it's added them together, divided by 6, and the average response is 4. See, you're trying to process that. And then you take the 6 effective statements, you go to transform, compute variable, and you would go effective. You double click on statistical, you double click on mean, and then you're going to insert.
But is this using the Likert scale? So the agree, strongly agree, is it?
Yeah, you're only taking the Likert scale statements and you're forming your constructs. Now you make, in other words, you've got 4 variables or 6 variables and you're turning that into 1 variable. Because you can't run any statistical analysis versus 6 variables. You have to have 1. So the individual statements mean nothing, but then collectively is what all the statistical analysis are. There's 2 ways of doing it. There's a way to transform, or when you do the regression, and when you do the factor analysis, you can save the variables, and then that will also do it for you. Okay. So we put in all the effectives, effective. You'll see how it comes together later, Sasha. So you do all the effectives, you click OK, and then it will create a new variable here called effective. You change the decimals to 2, you do nothing else, and then you'll see, if you go to data view, you'll see an effective column. So it's taken the 6 effective statements and calculated the average. You need this for all cross-tabulation calculations. You cannot do any cross-tabs. And now I want to see, is there a difference between the effective cognitive attitudes in terms of male and female? Is there a difference between age? Difference? You need that single variable. So now you've got these new variables for the cognitive, affective, and behavioral, which is actually 18 statements, but it's 6 statements of each summarized. So you have to be able to do that. Right. Now what you can do is, if you want the mean values of these, because sometimes instead of putting the individual means in that table, you just want to put the overall mean, then you can also just go to analyze, descriptive stats, descriptives, want to get rid of all of the individual statements, take it out, take the 3 new variables here, cognitive, affective, which is the 3 scales, and we click OK. And then it gives us the mean 3.14, 3 so you can see they're all positive immediately. Overall, the cognitive attitude was positive, the affective attitude was positive because they're above, but they're in the 3s, and this was a 4-point scale. It actually wasn't even a 5-point scale, so they're very positive. So that immediately, that mean tells you at least, okay, it is positive.
That's like the average of whatever. What are the 4 things again?
3, no, not across things. So in cognitive, you had 6 statements.
Yeah.
It's the average of these 6 statements for each respondent individually.
What were the? It was the scale, right?
Yeah, it was a scale. And there were 6. So let's just go back a step. Let's go to the question.
Sorry, man.
No, it's fine.
I mean, to use frequencies like, we used to, sorry.
Let's go to the questionnaire. So here's these 6 statements.
Yeah.
Measured cognitive.
Yeah.
So you've now put them together into one. There's 6 answers for each respondent. You've turned into 1 number now instead of 6 numbers.
Each participant.
Each participant. Okay. But you analyze them collectively. Obviously, that's what it is.
Okay.
So close current tab. Now let's see, you've created the groups. You've got the 3 new variables. Now you can start with cross tabulation. This is where the fun begins. t-test can only measure two variables. So if you've got gender, male and female, although these days you can have 10 categories. So usually I get my students just to put other, because you have non-binary, LGBT, and this and this and this and this. So I just get, usually that other is like 1%, 2%. It's very, very small. But let's just say, you know, she's male, female. You can do a t-test. See, now is there a significant difference between gender and their cognitive attitudes towards social media, towards tourist attractions in South Africa. So let's just run the test. So let's go in. I don't use t-tests. I prefer to use other tests. But some people, you know, if you've got yes, no answers, then you can use t-tests. But I use, again, other stats, which you'll see later, which is much easier. Analyze, you go to compare means, you go to independent t-test. So the test variable that we want to test, now you see, use the individual cognitive, and we want to test it against gender. And then you type in the grouping variable, define group, so it's 1, 2, always 1, 2, 20. Right? And now we go, okay. And now you can see that on average for cognitive, the mean for males is 3.16, females 3.15. There is no significance. What is significance? Let me just scroll down somewhere. I put it here, significance. Please note significant differences. If it's between 0.00 and 0.001, that's the p-value. It is significant at p equals less than 0.001. If the value is between 0.01 and 0.002 and 0.0010, it's significant at p equals less than 0.001. And if the value is at 0.011 and 0.50, it's significant at p equals less than 0.050. If it's anything above that, there's no significance. And you don't write that up. You don't write up cross-tabulation variables where there's no significance. You don't ever write it up. You only write up the variables that are significant for cross-tabulation. Okay. So if we go back to this SPSS, we can see, and to export this way, it's just file, export.
Okay, what happens if you, one of your research questions was looking at the gender?
You just say there's no significant difference across these variables. You don't put any of the numbers, nothing.
No, just
Only, but I mean, if it was part of your finding, so there's no significance at all, and you generally also put the t value in. So you use sig t mean the standard deviation. So how would you write up this finding? The independent t-test revealed, not that I ever do, because you don't write up it's not significant, but if it was significant, you'd write it up the same way. The independent t-test revealed no significant difference. P equals this, t equals this, so those values are here. You can see here is that sig is p and t is t. Between males, you put the mean and standard deviation, and females. Then people can see, oh, the mean values are the same. That's the one stat that people understand. That's the stat I understand. Don't fully ask me what the t even means. I don't care. You just put it in terms of cognitive attitudes. But if it was significant, you could say the results revealed that there's a significant difference. P equals, and then you'd say P is less than at whatever level, you'd get the mean and standard deviation. So you'd write it up the same way. Okay. And then I ran the test for the rest, and there was no significance between cognitive using the T. So that's your first little test. And you can also use it for yes, no. Right, ANOVA is more commonly used. So this is when you have 3 or more variables that you want to compare against something. And F ratios is what you include here. Is the larger the F ratio, and I think that's the same as the T, the larger the T ratio, the greater the significance. Okay, so now you can compare 3 values. So all of the other questions we had in this questionnaire, we go back. Just open this questionnaire. So now we want to compare, is there significant difference in terms of cognitive affective attitudes, in terms of South Africa, Africa, and international? Now, this is pretty much the essence of what you want to do, because your studies on tourist attractions, you want to know, is there a difference between the country of origin and their attitudes? So do this in, we'll just close this off. So to do this in SPSS, you go analyze, again, compare means, and we go one way and over. 8%.
It is general, the new model.
Yes, we're coming to that next. So now, I show you wrong that I'm doing this. I don't use the nodes, I use generalized linear model. So you go analyze, compare mean. The scale group is cognitive and the dependent move to dependent variable, and select the applicable independent variable region to the factor region. So we want the variable, the dependent variable. In other words, we want to see, is there a difference in the cognitive attitudes in terms of region? I'm just thinking if I need to post-hoc test. So ANOVA shows you that there's a significant difference, but it does not show you where the significant difference is. So I use the Bonferroni post-hoc test, which will show me where. Okay, so I click Bonferroni, I click continue, I click OK. And now it gives me the test. Is there a significant difference? 0.0431? Nope. F value is small. And it shows me here, this Bonferroni test shows me the differences. Are there any differences between these variables? It would show a little A here, but there's nothing. In other words, this is not significant at all, no difference. So let's go to a test where there is significance. So if we just go to back to the notes, close that. So here's the summary of results. So you have to run 1, 2, 3, 4, 5, 6, 7. You're going to run 21 tests to get these p-values. So you have to run each one separately in ANOVA, unless you do a MANOVA, which is a lot more complicated. So where was there? There was significant difference in access. So let's just show you what this looks, and then I'll show you how to write it up as well. So let's just say we go to the statistical analysis. Here we go, analyze, we go compare means, we go one-way ANOVA. We say cognitive, yes, we take out region, and we put in access. How do you access it? Back then you click OK. Now it shows you there's a significant difference at P equals 0 at 0, 0, 1. It gives you an F value, which is 8. And now here's the post-hoc test below. It shows you the Bonferroni post-hoc test. It's very small, I know, but here it shows you there's a difference between PC, and then you see these little A's here, and between tablets and mobile phone. And the laptop, it shows you there's a difference between laptop and tablets and mobile phone. These variables below will be the opposite. So it shows you the positive and negative. You don't need to look further. So now we know that, oh, I know what, there's a variable I didn't. I need to go analyze, I need to go compare means, I need to go, I'm not seeing the mean values. So compare means, I forgot to click under options. I needed to click descriptive. Okay, continue. Now we run the test. I see now it gives me the mean values. Right. So we know that those are different. So we can see that PC and laptop, the mean values are 2.94 and 2.94, whereas the mean values for tablets and mobile are 3.24 and 3.16. So this finding means that when people access Cape Town tourist attractions via mobile devices and tablets, they have more positive cognitive attitudes than when it's accessed by PCs and laptops. In other words, would that make sense? That finding would make sense because people always have their cell phones with, and if they're looking for information, they're going to do it right then and there. But if they have to wait to get home to their PC or laptop and do that, by then, the enthusiasm has waned. So how would you write this up? You would say, Respondents who use tablets and mobile phones to access social media showed more favorable cognitive attitudes, and you give the F value and the P value towards Cape Town tourist attractions using laptops. And so you would run these tests for each of these, and then you only write up the significant findings. So I've written it up for you, and I'll send you this Excel, this SPSS sheet. So if you want to practice this calculation, you have how to write it up, you have the results, then you can practice, because I'll give you the SPSS sheet. Yeah. And then log on frequencies also. But that you've got to do 21 tests. If you use a generalized linear model, you can do 3 tests. You can run everything at the same time, or cognitive, or affective, and behavioral. The difference is, though, that a generalized linear model is based on Wald chi-squared, and ANOVA is based on ANOVA. So the results could differ, which is to your advantage. So the results that give you the most significant results is the test that you would use. You can choose which a t-test, a ANOVA test, and a GRM could all give you 3 different results. So when you run, but you can't now do a t-test for this, and an ANOVA for that, and a GRM for this. If you use one, you pretty much, except for the t-test, which is what you've got to stick with it. Okay, so you're going to see that this GRM will actually give a different result to the test. So a generalized linear model allows you to compare all of the independent variables against cognitive, for example, at the same time. So let's do that. And my 4th year BTech students, advanced, use this already as well. So to do, let's just close this. It's much quicker to do. And journals don't know this test. So when you put it in articles, they never question you. It's not so well known. So you go analyze, generalized linear model, generalized linear model. Under response, you take your variable that you're looking at, cognitive, and you move it across. Then you click predictors. You take all the variables you want to cross-tabulate. So it's region, attraction, social media site, access, cognitive, gender, and age, and you stick them under factors. Then you click model, and you block the 7 variables you want to do the cross-tabulation, and you just click that arrow and you move it across. Then you go estimation, nothing, statistics, nothing, EM means. Again, you take the 7 variables, you move it across. You say you want to do pairwise post-hoc test, because generalized linear model, like ANOVA, does not show you where the significant difference is. So you want to do a pairwise post-hoc test, and you change this. I always use von Peroni. And then you click OK. And now it does all 7 at the same time. So it gives you this nice table, by the way, with your frequencies and percentages for all of your descriptive variables, which you could just use in a journal article just like that. You know? And then it now shows you the overall mean and standard deviation of cognitive variable again, and it shows you that there's significance. In other words, there was a significant difference for one of these 7 variables when comparing to the cognitive attitudes. And then it provides you a summary of each variable, and then it will provide you the full information below. So was there a significant difference for the region? No, no, no. How do you mostly access? Yes, that was the only one. So it's differing from ANOVA, because ANOVA found, I can't remember, one of these was also significant. But, and then just to do the other 2 tests, just to show you how quick it is to do the other 2, you go generalized linear model. I'll show you what to do. You go back to response, you take cognitive out, you put in affective, you go that. Boom, it's done the next 7, and you go analyze, generalized linear model, generalized linear model. We take out affective. Done. Those 21 tests you'd have to do in ANOVA are done. Right. Now you can navigate between the different variables. You can use this to get to, that would give you the second one, but here's the first one. So there is a significant difference. Yeah, so now you need to scroll down and find how do you mostly access to see where the differences were. So we scroll down. How do you access? You see it shows you the same 0.0 there, and now it shows you there's a difference between PC and tablet. There's a difference between laptop, tablets, and mobile. These would show you the opposite results. So now we can see again, it's giving you the same result. PC and laptop were different from tablets and mobile devices, except you can see the mean values have changed a little bit. Not exactly the same. If you go to now the next test, which we went for effective, effective shows you there's a significant difference for how do you mostly access at P equals 001 and how often do you log in to social media, right? Which was exactly the same for Nova. And if we go down to the next one, behavioral, it shows you that it's got a, there is a different value somewhere here. I can't remember where, it's not given it now. But again, these two were the same. And then to see the values, you scroll down to get to what was significant. This was significant. How do you access? And it's saying PC is different from laptop, tablets, and mobile device, whereas laptop is different from PC. So it's showing you a different result. It's only PC that is different because laptop's also mobile, isn't it? So it's showing you a different result from ANOVA, but it also makes sense. And then how do you write this up? Because I've still got two more tests, three more things to do with you. So let's just go to the notes. So I just give you all the how to do everything here. So you could write the means and standard deviations and p-values here. But here you would summarize it in the same way, except it's much easier now because you're not copying and pasting 7 individual values, you're just copying and pasting 1. But what this did show was different in the behavioral, I may have changed my data set a bit, is that it also, instead of finding log-on frequency significant like it did in NOVA, it found region was significant for behavioral. And therefore, under region, what did it find? It said a significant difference was found in South African respondents were more positive in terms of their behavioral attitudes than international tourists. So which would I use? Would I use a noble GLM for this stat? I would use GLM because GLM is showing a difference between the different types of tourists. Whereas, yeah, so not all 3 of these variables are significant. Now, this is not, but at least 2 others are. So this, in my opinion, is a more important finding than these findings. So I would use GLM. It's also giving 6 slots of significance. And then this is how you write it up. It's pretty much like an over, you write it up. You just give, instead of giving standard deviations, you get standard errors in a GLM. Right, so that's cross-tabulation. You can use a t-test, you can use the ANOVA, you can use GLMs, and there are many other tests. Those are the ones I use. But a lot of people in journal articles and theses don't do the cross-tabulation. And my opinion is they're missing out on valuable stats. I'd say 9 out of 10 theses I see that don't do the cross-tabulation. 9 out of 10 journal articles I see that don't do the cross-tabulation. But what you do have to do now is regression. We had a hypothesis, did we not? So if we go to the hypothesis at the beginning and how to create big tables, we had this hypothesis. Cognitive has a positive influence on behavioral. Cognitive has a positive influence on affective, and affective has a positive influence on behavioral. How do we test that? We can test that via regression. And that's very easy. So regression determines the strength of the relationship between the independent and dependent variable. So whatever the variable is being fed into is the dependent variable. So if cognitive feeds into affective, affective would be dependent, cognitive would be independent. If cognitive feeds into behavioral, behavioral's dependent, cognitive is independent. Okay? So it determines the strength via estimized, standardized beta coefficient. Beta is summarized by this. The closer it is to 1, 100, the stronger it is. So it can only be 1. Okay? So how do we do this? So let's show you. Very, very simple. And you can create big diagrams just with those beta values. So you go to analyze, you go to regression, you go to linear regression. So we want to, the dependent variable, we're going to say is effective. And the independent variable that feeds into that is cognitive. So say cognitive positively influences effective attitudes. We go to statistics. What do we want to click? We don't want collinarity or anything like that yet. Let's just see in the notes what else I tell you to click. Log on, regression. Okay, we're not doing any of that now. So we just go, okay. So you can see here what values. Is there a significant difference? Yes, there's a significant difference at p equals 0.001, right? So that is the one important figure we want. The other important figure we want is the beta coefficient. It shows it here as R 0.547, or it shows it here as beta 5.7. So there is a strong influence. Above 0.5 means there's a strong relationship. Cognitive attitudes positively influences affective strongly. The other value we want is the R squared, which is 0.299, which is actually not so good. It would be better if it was about 0.5 for social sciences. But the more important figure is the standardized beta coefficient and the significance. So even if the variance is a bit low, you know, you can get away with that. So how do you report on this? Let's just close that, those notes. Just here, go back here. How do you report this? And what does it look like? Let's just here. So we'll get it back to analysis. Go over a little bit, so back down. Yeah. So you'd say that cognitive exhibited a positive effect on effective attitude to report the t value, the beta value, and the significance level. So if we go in here, where do we find all those figures? Here's the t value, here's the beta value, and here's the significance. So this last graph, you take these three values here, beta, t, and significance value, and you'd say first as a positive t. Then if you do the same test, tourist cognitive also exhibited a positive value on behavioral. So if we change this test, now you can leave this and just do the next test and then export it all. You go analyze, regression, linear regression. Now we throw out effective and now we put in behavioral. We click OK. And here we can see it is significant at t equals 0.1. The beta is 509 and the R squared is 25.99, not so great. And then you could do the last test, analyze, regression. Last hypothesis was, take both of these out. We said that effective positively influences, other way around. Behavioral is the dependent variable, effective is the selection variable, right? Out here. Analyze, regression, linear regression. Yeah, I've done the wrong thing. Now we keep cognitive as the dependent and we go effective as the and now we find 577, the beta, also significant, and t 13.1. So they're all significant, all about 0.5, the beta values. And so how you write this up is you'd say tourist positive effect, tourist and cognitive positive effect, and tourist effective exhibited effective positive also. And then you could create your diagram. And all you do is you put the beta values, you put 3 dots, significant at p equals 0.1. So that's excellent. And you also need to put the R squared values, the variance in which weren't so good. Now, you notice cognitive and affective both feed into behavioral. So you want to actually run the stats with both of them feeding at the same time so you can get the R squared. Because if you have individuals, you can see the R squared here is showed above, is quite low, 259. So we can go analyze linear regression. And we want to get both variables going into the car. So we can put cognitive here as well. Just for the R squared value to see if that increases the R squared. And if you go in, it does. The R squared is 38.6. So it increased it from the 20s to the 30s because you have two variables going into behavioral. And then you could then put in the R squared values here, 386 and 299. And that's, therefore, you've tested your three hypotheses. And that's what your diagram would look like. And now you can create big diagrams like that, just doing regression between the different relationships. So, right, so that's regression. So that's just about everything in that chapter, except we haven't done the biggie, factor analysis. So you could usually do factor analysis much earlier, because this will show you whether these each of the six variables fit together. So usually after I've done the frequencies, I do reliability and factor analysis immediately. But I did it at the end of the presentation because it's the biggest thing. And I didn't want to do it earlier and blow your brains, because now your brains are already tired, but you can come back to the video and look at the notes. But I didn't want to kill you with that immediately. So factor analysis is basically going to group the variables and using confirmatory, to confirm the validity of your variables and do they fit together. So, yeah, do they fit together? So the rule of thumb is, so she had 18 statements. So you should have 10 respondents for each Likert scale question. So the minimum number of respondents she should have done was 180. However, if you're going to do cross tabulation now and you've got six variables and you've only got like 180 and now you're dividing 180 by 6, it means you could have two respondents for some. So it's better to have more stats. My master's students, the minimum number of questionnaires I let them do is 500. I've had master's students have 3,500 respondents. Okay, because they've had lots of cross tabulation variables. But okay, there was my undergrad students collect the data for them as well. So that's why it was so big. They didn't just collect. So, but 500, if you've got 500, you should cover all your bases. Okay. And I've got an article, a journal article to support that. You don't need to go bigger than 500. Anyway, so you need to make sure you have enough respondents. And now we're going to run this test and then we'll look and see. Let's just show you how to do it. So let's go back to this now. So we go in, you go analyze, you go data mention reduction, you go factor, right? We only want to move the 18 Likert scale items across. We then go to descriptives. We're going to collect KMO. This measures your sampling adequacy. We're going to click continue. We're going to go to extraction. We're going to collect screen plot. We're not going to fix the numbers, but here's the thing. If I click fix numbers, you've got 3 constructs. What happens if it decides you've got 4 constructs? So you can force it to a fixed number of constructs by clicking fixed constructs and type 3. It will force it then into 3. Okay, it depends how good your stats are, and often you have to play, and often you have to delete variables and get it to fit. So it's not going to be as simple as this example shows. So you click that, then we go to rotation. I always use Promax. Continue. Scores. We're not going to save variables, but if you want to save the 3 variables it creates, then instead of transforming and changing to cognitive, affective, and behavioral, you can click save variables and it will save those variables, which I'll maybe, if there's time, show you later. And then options, we're going to just suppress the size for now of the factor loadings and make them 4. that, yeah. Then we click OK. Now it's going to take a good minute to think about this. It's take a minute to process. This is big numbers. Wait for it to make it ready while I think about it. And I'm just going to take you through what the different things mean. Okay, yes, decided to go. There we go. So the first number gives it this KMO of 9.095. That should be above 0.7, so it's excellent. The sampling adequacy, and it gives you a significant level for Bartlett's test of sphericity. And just to show you, it says the KMO is utilized to evaluate the sampling adequacy, which is 0.50. Bartlett's sphericity is a tough word. That test was significant, so it shows that basically the sample was adequate. Okay. Communalities is the next thing it shows. This whole long list, there should be above, I don't know, I think 0.3. I never report on it, but it says shows how much variance explained among the variables. Low values are less than 0.3. But this shows that all of them are on 4s, 5s, 6, and 7s. I don't report on it. Now we get to this diagram, which is very important. It gives you total variance explained. How many attitudes, how many constructs did you have? 3. You had cognitive, affective, and variable. How many variables should be here? 3. If you've got 4 or 2 or 5, then you're going to have to force the factor analysis to combine it to a certain number of variables, to 3. But these eigenvalues should be about 0.1 ideally, otherwise you're going to then don't bother with structural equation modeling afterwards. Just use regression if they're under 1, because you're going to run into problems. Right, so what that means is the PCA, the principal component, said there were 3 values larger than 1. The total variance explained was 57, so it's about 0.5, so that's good, which is into a good correlation. The scree plot shows a distinct change in direction between 4 and 5, which means that you would retain the 3 variables before, and this is the scree plot. It's just that makes it fancy in your thesis. You never use it anywhere else. There you can see there's a kink between 4 and 5, which means that you've got 3 variables. And then the most important diagram is the pattern matrix. So this shows you, you can see all 6 cognitive variables are grouped together and all the values are above 0.5. Well done, it means you've got convergent reliability for your 6 variables. And it shows that all 6 effective variables are grouped together and they're all above 0.5. It means you've got convergent reliability for that. And all 6 behavioral variables are together and they're all above 0.5. It means you've got convergent reliability. These values you copy and paste into. So I just showed you all of this into this table here, except you would rerun the stats and you would not then say reduce values to 0.4, and so you put it in a table like this, you would block it and say these 6 and these 6 and these 6 put together, and then you cut and paste these variables under the FR value. Sasha, this is what you were wanting to know where they came from. So they come from the pattern matrix from the factor load-ins, and they need to be about 0.5. The problem is that for most questionnaires, you run it in, you're going to find this is going to be a mess if your questionnaire was not put together properly. And you're going to find variables, you're going to find a 4th or a 5th row, and you're going to find this is going to tell you when you need to delete variables. Because you're going to have variables, you're going to have maybe you could have 4 of these variables together, and the other 2 are either below 0.4 or they're shown in a different column. That is when you start deleting items in your Likert scales. Okay, this is an ideal example. It doesn't work like that in ideal world. I've never had a student where I haven't had to delete at least 1 variable. So if you delete a variable, you could report it and say a variable was deleted because it was not, didn't fit. The validity was poor, the factor loading was low. Usually what I do with my students is I say, just delete it from your questionnaire. It was never there in the much easier. So that's your pattern matrix. Then you've got this component correlation, which I'll get to later. So now you've got your pattern matrix. That fancy thing I showed you in the first chapter is there, nearly there, and now you can put the FL. There's two values we don't have, AVE and SR, composite reliability. SPSS can't produce this. So Corey Ace and I about 10 years ago developed a template that you can use to get these values. If you use Amos, you can get these values, but not in SPSS that we know of. So now you want to calculate validity. I will also email this template to you. It's got 10 constructs. You can use it. So, and it's very simple to use. And so here's this template, validity calculation template. And so it allows you to do up to 10 constructs, up to 7 variables for some. And all you do is you cut and paste in the factor loadings. So we take these, or you can cut and paste it from here. We take these 6 factor loading. Oh, no, not going to work from here. And it's not going to work to go into a Word version. Let's just go into it's really the last thing here. So we go to the factor loadings here. So you take the 6 factor loadings from here and you go copy. You take it into this template and you put it in row 1. You go paste. It's got 7 here, so you delete this 7th row here, you delete that, and then you can call this cog. Let's just call this immediately effective, and let's just call this behavioral. And then we go back to this and we take the 6 effective construct factor loadings, so copy, put it into this template, into row 2 where you see B1, paste. We delete this. It only got 6 items, so we delete that. And then lastly, we take 6 items from this, the behavioral, and we go to the template. We go to C1 and we go paste and we delete. Oh, that's only got 6. And then this, we just delete this as well. We've got only 3 items. And then we go to the fact analysis and we take this component correlation matrix test here. We copy this one table, copy. This is going to be for your discriminant. And I just copy and paste it below here. Paste. And then we just take these 2 values. One, I'll talk about that later. And we paste it there. And this value, we paste it here. This is for your discriminant validity. Okay. Now, this has done all the calculations. There's your average variance extracted for each of the values. This is a bit low at 498, but it's just about 0.5. And here's your composite reliability numbers, all calculated for you. So you take the AVE and CR and you stick it in over here, AVR, CR, and you do the same for effective and you do the same for behavioral. There's your table done, which has all your reliability values. You can see that all these composite reliabilities are above 0.7, and all these AVEs, like the FLs, are above 0.5. So you've proved convergent reliability, and you've proved reliability. And then I'll just show you the last test is the discriminant validity test that you need to know. And this we use for now and Larker's formula, which says the square root of AVE should be greater than these values here, greater than the component correlations. So this, we took the component correlation matrix and we put these were the correlation values. And then it automatically in this table automatically took the square root of AVE, these 3 values, and you can see 0.7, 0.7 are greater than these values. So therefore you proved discriminant validity. In 99% of the theses I see, there's no discriminant validity measures. I didn't know what that was when I did my thesis either. So I made a point to find out how to calculate this so that my students have discriminant validity. And then how you write it up is I show you reliability, show good reliability of values between where was this? Oh, that was a test. This is ABE, so good discriminant, but CR above 0.8 and above 0.7. And the AB values were ranged between 498 and 600 and 53388, showed convergent reliabilities. And then I showed you how to create the component reliability. And here's the thing, square root of AB and attitudes shows good discriminant validity because the AB square root of AB is greater than the correlation between the constructs. And then lastly, I show you a regression alternative where you can save the regression values, but I've already covered that. So now you know how to do this figure, and you also know how to do the little discriminant validity. But this is very small. If I just, for the last, we've just gone 5 minutes over. Do you want to save this? No. If I just go, do you want to save this? Don't save, and no, and close that. If I just go to Word, and I'll go to the students example that I showed you. Now you know how to create all these graphs. All right, showed you that. I've showed you how to calculate the means of the overall by transforming data. I've showed you how to create the Likert scales by combining the different graphs. You can see this eigenvalue from the factor analysis should include just as it is in the chapter. And she had 7 constructs. I've shown you how the skew plot, her kink was between 8 and 9, or 7 and 8, so therefore we take 7. I've showed you how to create the pattern matrix. So this would go in. And here's this diagram that you see in most graphs, this table. So how to do the mean standard deviation, the factor loadings and average variance extracted is convergent reliability, the composite reliability and convergence reliability. And I showed you how to calculate this composite correlation matrix where the square root of ABE needs to be greater than the correlations between the constructs, and they all are. And again, we don't do that. And then you know exactly how to calculate all of these standardized beta values, which you could do through linear regression. And these are squared, you know, they're also included in the linear regression values. And then lastly, I showed you how to do the cross tabulations using generalized linear model, ANOVA, and t-test, which would land you up with a table where you did, you know, the cross tabulations. So now you're able to do this chapter. Obviously, it's information overload. You need to watch the video. You need to take the SPSS sheet that I will send you and practice these calculations to see if you come to similar types of values. And it's a lot of, you know, I mean, this is like, but this is all the information you need to do if you're doing quantitative analysis to do thesis. Naturally, you can go higher grade and do structural equation modeling, maybe at doctoral level. At master's level, you can definitely get away with regression, even doctorate level, because I didn't even have that in mind. I just used the GLM for everything. So I didn't do any relationships between, I had no hypothesis in my thesis, doctoral thesis. I only had research questions. So, are there questions or your brain's fried? So what I would like you to do is come and type your email. If you want the video and you want the documents, come and type your email address here, and then I will I mean, it is on Blackboard, but I know some of you are staff and don't have access to Blackboard. I can only retransfer to 3 people at a time, but I'll retransfer all of these documents to you tonight. Okay, after I get back the video. And this today's video, there's also yesterday's video. I can also give it to you if you want, but it's the same presentation. I mean, not yesterday, Tuesday. It's the same. I think today I presented it actually better. So just stick to it.
So I'm going to stop our recording.
Stop. Then do you want to review? No. And I need to just quickly go into Teams. And I was recording there. Stop recording. Stop. That means I've got those two videos.